Okay, hello everyone. Thank you for joining us today and welcome to Production Modeling Corporation's webinar presentation, Visualize and Optimize Operations of FlexSim Simulation Primer.
Now for a little bit about myself, my name is Nicholas Alejandro Obeso. I'm a senior simulation engineer here at PMC with the Simulation Services Department, and I studied industrial engineering at the University of Pittsburgh. I've been with PMC for a number of years now, but only recently have started making use of FlexSim. To start things off, I'd like to do a brief introduction to PMC. Since 1979, PMC has helped over 700 companies by completing more than 8,000 performance-enhancing initiatives worldwide. Our commitment to excellence has brought us to the point where we are the largest independent industrial engineering services firm in North America. In addition to our U.S. office, we have engineers in Mexico, Brazil, and India. PMC has worked with hundreds of businesses across all industries to improve their business performance. Shown here are just a few of our current and repeat customers. Today's session will focus on FlexSim and discrete event simulation, but we will continue with a sampling of other services that PMC offers. PMC has a wealth of services to offer and the expertise to go along with them. Some of these services include factory design, laser scanning, and CAD modeling, Lean Six Sigma, quality and operational excellence, and also traditional IE services. If you're already underway with productivity improvement initiatives in your company or are wondering where to start, PMC can help you. Now, with my long tangent at an end, that brings us to the presentation in earnest. I'd like to start things off with going over some industry challenges that we might face and how we can solve these problems using simulation. So on the left I have all the headers. You have the area on top, the problem in the middle, and then the solution in the bottom. So starting off on the left, we have production line optimization. We want to identify bottlenecks in production and improve throughput. That's a given. And we can model the sequence of operations, we can model resource allocation, and we can get results on equipment performance and really test various configurations and schedules and have a quick turnaround on those modifications. Next, that brings us to capacity planning. We want to be able to balance production demand with resource availability, and we can use simulation to predict the effects of scaling production, introducing new machinery, and adjusting workforce levels before we actually incur those costs in the real world. Next, we can use simulation to optimize our material handling systems. We want to ensure efficient movement of materials within facilities naturally, and using simulation we can evaluate different conveyor systems, which is something that FlexSim is fantastic for. We can model AGV systems and test different material handling operation procedures, and then in general improve flow and reduce delays. Lastly, I have automation and technology integration, which kind of builds off of some of these other categories, and we want to test the impact of new technologies before adoption. As we know, the virtual world is a lot less expensive than the real world. So for example, we'll be testing AGVs or robotics. We can model the integration of new automation systems. FlexSim has an AGV library, has robotic arms, has all that good stuff. And we can forecast those effects on production speed, labor requirements, and overall operational efficiency. Now that brings us to the star of today's show. FlexSim is a piece of discrete event simulation software, which I've become very acquainted with recently, and I've had an absolute pleasure using. I found it to be very thoughtfully made, and it's really made my life easier as a modeler in many respects. There's a lot of features in here that really make the whole modeling process seamless, and I hope to go over some of that with you today. So jumping right into it, FlexSim is a software that we can look at in a top-down 2D kind of view and also a 3D view. The 3D models that come with FlexSim are, in my opinion, very nice, but we also have the option of creating our own visualizations and importing them into FlexSim, but we also have some animation and kind of visual building tools within FlexSim itself. Something else that I've added onto this slide is the ability to toggle between a perspective view and an orthographic view. This is kind of a minor thing, but something I've appreciated quite a lot, because when I'm grabbing a recording of the model for a client, for example, using that orthographic mode, which is what you can see in the middle, I'm able to fit more easily the whole model in the screen. So just kind of a little convenience, but really something I've appreciated. Next up brings us to the objects that FlexSim has. FlexSim has a fully featured object library. Starting off has all the kind of standard objects that you'd expect, so your sources, your queues, your processors, but it also has a number of more specialized libraries. Conveyor is going to be a big one, and one that I will touch on in further detail. There's also a warehousing library full of racks and that. FlexSim has AGVs, so the AGVs themselves, but then also the traffic management for it. There's a fluids library, so for tanks and plumbing. There's a kind of people slash medical library, because FlexSim has a medical kind of mode, a healthcare simulation mode that you can boot into. And then another one that I've added is the A-star navigation, which is kind of an agent based pathfinding algorithm that you can set up, so that if you have operators in your model, instead of having to kind of build rails for them to walk on, you can have them plan their paths around obstacles and walls and things of that nature. So something that makes the model a bit more realistic, but also kind of maybe saves you a little bit of effort having to draw out all of those paths. And then I also have an animation going on where you can see kind of a bit more of this library of objects. Moving on to the conveyor library. This is a library that has many objects and options. We have, your kind of standard conveyors. We have mass flow conveyors if you're doing something like a bottling plant, a flow shop kind of operation. There's a number of parameters that we're able to play around with to really mimic the behavior in reality. So we have speed naturally, we have acceleration, stopping and moving space, we have delays if a conveyor has to restart. We're able to build slugs, so release parts kind of in a group rather than just sending everything one by one. We have decision points that we can use for more complex routing decisions, but also to have like area restrictions for a bit of traffic management. We have stations where we can do processing on. We have photo eyes that we can use for sensing, and then merge controllers again for kind of traffic management. And so a lot of like the features and functionality that I would ever possibly need to build a conveyor model, kind of like what you see on the right, for example, that's all in FlexSim to begin with, so you can kind of hit the ground running when you start modeling. There's also some fantastic visualizations available. We have roller conveyors, which is really the bulk of what you see in this picture. That's what all the silver conveyors are. We have belt conveyors. Again, there's the mass flow, which has its own kind of visual, but you're also able to, like with any object in FlexSim, you're able to make your own custom appearance for things. Now that brings us to a section where I want to go over some of the ease of building that I've found using FlexSim. Start off, FlexSim makes use of 3 types of port connections to link objects. You have your input and output, and also a central port that gets used for kind of communication, data transfer between objects. You can be a little bit creative with how you use it. Connections are very quick and easy to make. So what you see in this animation here is me holding down the A key and clicking on the source to the queue to then the 3 processors in order to make that connection. It's very easy to make connections between multiple objects, which is again something I've featured here in this animation. So I'm selecting all of the processors and then just drawing one connection from the queue to one, and that automatically connects that queue to all 3 that I've had selected. And then another thing that I really like is the ports window that objects have. So sometimes it can be a little tricky to keep track of all the connections you've made to an object. Occasionally also, if the order in which these connections are made is of importance, that can also add a lot of complexity. So this ports window is really nice to just keep track of everything, check your work and make sure you haven't missed connecting something, and then you're able to also reorder connections or remove them if need be, if something has gotten messed up. So just a convenience that I've really appreciated because unfortunately not everything has that kind of feature. Now that brings us to the logic section. FlexSim has two ways of programming logic in it. There's a FlexScript language, which is a C++ derived programming language. And then there's the process flow, which is a 2D flowchart style logic builder. That's what you see here on the right. This is a sampling of some logic that I put into uh, one of my models that I worked on recently. This was to control some conveyors. I had some kind of special behavior I had to model. These two ways of programming logic can be used in conjunction with each other. And so here I am using some code blocks to stop the conveyor and resume it or reverse its direction. I'm not sure if that comes across in the picture, if it's too small, but it's there. Um, FlexSim is a tool that I find you can get into very easily if you're a novice, but there's still a tremendous depth that you can explore as you become more proficient. And this really lends itself to that you can start with process flow and just do things very intuitively in this kind of visual environment, but you can little by little start incorporating more and more FlexScript into it. And indeed, FlexSim does offer a lot of kind of commonly used FlexScript commands, like for example, to stop a conveyor that you can, incorporate from the beginning and maybe kind of see how they work and learn from that. Models you can actually make them entirely in process flow, so that would be like a strictly 2D flowchart kind of tool. But more frequently, like in this case, you're using process flow to control objects within the model itself, and add some more functionality to them. A nice thing too with process flow is that you can see the individual tokens. That is the representation, if you will, of an object moving through the flow chart. And you can also color them by like a label, so say like product type or something, and that really does aid in debugging. It's really nice to see the process flow working in real time and see those tokens moving through it. Next up, we have lists, which are another flexible tool that FlexSim has to offer. They are kind of, as the name suggests, lists where you push some kind of entry, which could be representing, say, like a product, and then it's later pulled. So entries can be partitioned and given fields based on a label or expression, a label being, in a sense, a variable that you're applying to like an object or a token. And so that's what you see on the top right. Those columns are labels that I've applied, so age, type, and then age in queue, which is really time in queue. And then there's partitions based on product type as well. And so you can query lists using SQL to filter what it is that you're pulling and also to prioritize it. So if you are, for example, using a list to set up material handling operations, you can sort it based on like the longest time in queue, for example, if you want to prioritize that way. And then additionally, if you're doing like a pull style production, which this is a great tool to kind of set up, if you have certain pieces of equipment that can only perform certain operations, again, you can use something like a label or a partition in order to only look for entries that meet that qualification. And then, this is also really great for whip and final assembly. So if you have like multiple racks where you have like sub-assemblies and components stored at, instead of having to query every single rack one at a time, you can have all those parts make an entry representing themselves into one kind of centralized list, which then you can access and then pull a reference to the parts that you then have to pull into final assembly. And then that second picture down at the bottom right, that's the back orders. So that's now from the perspective of the puller rather than the pushed, which is what the entries are. Next, we have tables. Tables are a big part of, I think, every simulation model. And FlexSim tables are Again, really nice and convenient to use. We can store every kind of data that we would need. So, numerical data, strings, pointers for objects, so that you can use a table for routing, which is something I've done quite a bit, especially when you have different parts with different routes. You can store arrays, little bits of flex script, and then some other specialized data types. You can import or export them to Excel, and you can also append to them during a simulation run. So it's not necessarily just something you'd use on the input side of things, but it's also something you can use as an output. So indeed, this example that I have here on the right is a log, which is one that I had at kind of the exit, if you will, at the sink in the simulation model that this came from, where each part that exited the system, logged certain statistics there, and so that got just written to as the model runs. And then just like the lists, we can query them using SQL. So if that's something you already know, it's really convenient, and if not, it's pretty easy to pick up. Next up on inputs, we have the parameter tables. Parameter tables are where we can store and update any input parameters really. So cycle times, capacities, levels of labor, rework rates, anything like that. And that's just a central place where we can just change a value here and have that connected to our simulation objects, and those will update themselves automatically. We can also give these parameters a range of feasible values, and then that kind of plays into the experimenter, which we'll touch on the next slide. And now on to the experimenter. In the experimenter, we have a hierarchy, and we have jobs and then scenarios within those jobs. So a scenario is going to be a simulation run where you have a certain combination of parameter values, and then those scenarios have however many replications you run them for, and those all fit into jobs. So you can create jobs with different scenarios for organization, but there's also three kinds of jobs, right? And I'm going to go a little bit out of order here because I'm going to save the best for last. You have an experiment job, which is kind of your standard. You define your own scenarios, you set those values. You have range-based, which is using that feasible range, which I had previously mentioned, for the different parameters, where the software will automatically generate scenarios basically from the minimum to the maximum possible value. And then lastly, we have optimization, which is where we define an objective and constraints. So an objective function, say we want to maximize throughput, and we're constrained by the cost of labor or like a limited amount of equipment. And then FlexSim will generate scenarios basically tweaking those parameters in order to find the optimal set of values for that objective. And then the user can select what kind of jobs, scenarios, and replications to run. So if you don't have to run everything at once. You can redo one replication, you can redo one entire scenario, or you could just run a whole job all the way through. So you have some options, some flexibility here, and really having that built-in optimizer is a really, really nice thing to have, and not something that's super common in the kind of DES world. And now last on outputs, we have the dashboards in FlexSim. In simulation, visuals are king. So when you're communicating to stakeholders, communicating to the client, dashboards are really an invaluable tool to have. They make outputs readily available to us, both for the modeler, but also, of course, the stakeholders. FlexSim has a large selection of built-in graphs which can display statistics on everything you would possibly need, content, your output, your stay time, all that good stuff. You're able to define your own dashboards as well. But really, I found that what's in there to begin with has been more than enough for me. You have user selectable styles, so something like a chart on utilization, we can switch between a pie chart or something like a bar. And we can also mess with the color and all that. So you don't have to export things into Excel and go through that extra labor of making the graphs. Making them is very easy. You just drag them into the dashboard window and then select an object with the dropper tool. Um, and then everything can be exported as well. So dashboard charts, you can export them as a PNG, as a CSV file, which is where you get the numbers that are basically being read by that given chart. So if you want to, go through the actual tabular data or make your own chart later on, you have that option. And then you can also export them as an HTML rather than an image. And this is actually particularly nice because when it's in an HTML view, you can click on it on that file. It'll open it up in a browser, and you retain the ability to interact with the chart. It's not just a static image. So I can resize it, and I can, you can see kind of on the right, there's a scroll bar on the bottom of some of these dashboards. So if you export it as HTML, you're still able to scroll. And lastly, everything has some number of inherent statistics, and by that I mean any object, you can just click on it during the model run and in real time see how many things have gone into it, how many have exited, what the average content is, stay time. It's going to depend on the type of object that you're clicking on. But during the modeling process, it's very useful just to make sure that things are operating properly and that things aren't stuck, if you will. Now that brings us to the demo. I am going to exit out of here and pull up our model. So I have a blank view open here. Um, we are in the working mode. So here's that option for perspective projection. I'm going to turn that off, and then I'm just going to reset the view so I'm just facing top down. This is just happens to be how I like to model. So I'm just going to do something real basic. We're going to bring a source in. We're going to bring a queue, and we are going to add 3 processors. So very similar to what we saw on that one slide. And then I am going to add another queue on the output. And I'm going to add a conveyor. Let me do to put another conveyor going down this way. And lastly, I'm going to put a sink. So the first thing I'm going to do is snap that conveyor together so we see there's a connection here. I am going to just connect everything together. So I hold down A to set the cursor to the connection mode. So I'm going to click on the source, click on the queue. We have that connection there, and you're able to toggle the show connections on and off. But since we're modeling, we're going to leave those on. Then I'm going to select the 3 processors. So I'm going to hold down Control and drag. I can also hold down Control and individually click to select. Then I'm going to hold down A again, click on the queue, and then drag just to that first processor, and it's going to create 3 connections. So if I go to the queue and go to this ports window here, I can see the input, it's connected to the source, and then the output, it has all 3 processors. Now if I want to rearrange things, I can click, I can select one and then use the arrows to increment it up or down. I can delete something from there, and if I wanted just to add something to the list of outputs, I could draw the connection, or I could also use the dropper. So the dropper tool, you get use it in the dashboards, but you really use it everywhere. But that just allows me to select that object again. Now what I'm going to do is say select, actually I'm going to add a third queue. I'm going to have them each have their own output queues, and I'm going to add another conveyor here. So we're going to kind of stagger them. I'm going to snap that in like that. And so I pressed shift click and then clicked out to deselect. So I'm going to connect each processor to its respective queue. And then I'm going to connect this queue to this top conveyor here. I'm able to change where the the entry point is, and I can also resize it. And that's useful if you have like an operator picking things off of the conveyor. It gives them like a wider area that they can kind of catch the moving object rather than just having to go to one fixed point in space. This one I'm going to connect here in the front, and then I'm going to connect this last one here. And I'm just going to have this one start at the tippy top. And now I'm going to add 3 decision points. I'm going to add one here, and one there. And to quite a complicated junction here. So what I'm going to do is create an area restriction where an incoming object has to seize basically possession of this kind of junction. So I'm going to connect this here, this here. I'm just connecting each decision point individually to um, the photo eye. And then for all of them, I'm going to select them. I'm going to add an on entry trigger. So this is something that happens when a certain event takes place. So we're going to use on arrival. And I'm going to say area restriction. I'll say acquire area. And it's just going to acquire the out object, in this case, the area that's owned by this photo eye. And then at the photo eye, I'm going to deselect those. I'm just going to make sure that all of them have that. Yep. Here I'm going to say on cover. So that's just when an object is no longer covering it. I'm going to go back to area restriction and say release area. And so the area owner, it's current. That means that it's the one that's owned by the photo eye itself. And I can introduce a delay time as well. The last thing I'm going to do is connect this here, the sync. I'm going to reset my model and then just make sure that things are working the way they're supposed to. And that looks good to me. We could be a bit more particular about things and give a different object kind of product type so that type 1 goes to processor 1, type 2 goes to processor 3. But I'm not going to mess with that. But yeah, so it looks like our traffic routing is working well. I can slow this down a little bit, maybe not too much, but yeah, that looks great. So now let's add a dashboard to it. You go here and add a blank dashboard, and we can say add average content. Yeah, we can do content over time. So we'll click that there. And I'm going to sample this conveyor. I'm going to reset it. And then I'm going to run. And here we can see the content fluctuating over time. We can resize it. And then if I say stop it. Well, we haven't run it long enough, but once this gets populated a bit more, there's going to be a scroll wheel. As you can see, it's kind of reached a steady state. There's not enough going on that would really cause any fluctuations because it's just going straight to the sink. But hopefully that gives you some idea of how things work. Now, so that concludes our presentation. If you have any further questions or want to, reach out with an inquiry, please reach out to Carrie Van Loon or myself. We will be taking some questions from the audience now. But yeah, if there's anything more complicated, please feel free to reach out to me via email. Thank you.
Awesome. Thank you, Nicholas. So you did
Yeah.
get a couple of questions through the presentation. Did you, let's see, when modeling several different types of conveyors in a process, can you easily change the spacing and speed? And I think you demonstrated that during the demo.
Yeah, so the spacing and speed, since they are kind of like object properties, that is something that if we have a bunch of conveyors, we can link that to a parameter table. So if we start a project and we understand that the conveyors have X and Y acceleration and speed, but then that changes. If we have that already hooked up to a parameter table, we don't have to go in and change that on every single conveyor. We just tweak that value. And then again, if that's something that we're testing, maybe how production is going to look with one specification versus another. In something like the experimenter, that we could make different scenarios with varying specs on said conveyor.
Okay. Um, Thank you for that. And can you build a dashboard with KPIs? Is it easy for them and their customers to change?
I think the 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 dashboards that FlexSim already comes with are going to cover a lot of what those KPIs could potentially be. They are themselves easy to add into the model. So I guess in that regard, I would say yes, that it is easy. But if the KPI that a particular client is interested in uh, is not a common one, or is one based on some, you know, yes, I guess a novel calculation, then you're still able to define a custom value and plot it over time as well. So you could use something like a tracked variable, which is like a statistic that's you can define how it gets its value assigned to it, and then have that be plotted essentially on the dashboard. So a lot of what you would need, I guess in summary, a lot of what you would be plausibly uh, wanting to display to the client already comes with FlexSim, but you still are able to define whatever it is you need on the dashboard.
Okay. As long as you have the math to back it up, it can be displayed.
Hmm.
Okay. And then if we had one more come in. When modeling multiple machines in a row, how large of a buffer do you model between the machines?
Well, I suppose that's something that you would use the model to find. What size it is that's necessary. So s- if you use the dashboard for something like content over time, you're plotting the content of a queue across the entire simulation run as a line graph. You could do is have a queue that is effectively limitless in space and see where where that content is kind of hovering around, and that would give you a good indication of, okay, we need actually this much capacity on our whip area. So that is more so, I think, a question that you would be answering rather than something you would set arbitrarily to begin with.
Okay. So it's situationally specific, right?
Yeah, that's something that you'd model and find the answer to.
Okay. You also have another question here. Can you use cloud computing for running simulations because some complicated ones take a long time to run?
Um, that is not something I particularly have experience with, but I don't see why you wouldn't be able to have something like an Azure client and just install your FlexSim and have the license on a cloud compute uh, unit and then just run it there. I'm not particularly familiar with the intricacies of FlexSim as far as its use of multiple cores or hyper threading and things like that. So that is something that I think I would reach out to Autodesk about more than anything.
Okay, fair enough. I don't see any further questions, so thank you, Nicholas, again for your presentation. If you have any questions about procuring Autodesk FlexSim, please reach out to us via Carrie Van Loon, and Nicholas is happy to answer your questions if you have them over email. So thank you guys so much. Thank you, Nicholas.
Thank you everyone for joining.